Hi, my name is Marie Pellegrini, and this is my recording for Project 3 for Intro to Authoring Tools. Today I'm going to be teaching a lesson about solving problems with common factors using the Make-A-List strategy. This is from the Go Math series, 4th grade math, and today's lesson is 5.2, problem solving with common factors. So just as a review from yesterday's lesson, a word that is really important that we need to know for the lesson, the word factor. A factor is a number multiplied by another number to find a product. And an example is 1 times 18 equals 18. So 1 is considered a factor and 18 is considered a factor. And the important word product is the answer in multiplication. So just to start off, we're going to start off a little small, and we're going to find the factors of 18. So that means all of the numbers that you multiply together that equal 18. So there's 2 ways we can do this. One way is linear, and then another one is the table strategy. It depends whichever one you feel more comfortable with and is easier to work with, you may use that one. So we always start with 1, the factor 1. We want to keep our numbers neat and organized and in order. So we start with 1, and we know 1 and 18 equal 18. Don't forget our commas. The next factor, because we go in order, is there anything that when I multiply 2, I get 18? The answer is yes. 2 times 9 is 18. Then continuing in order, 3, any factors that you multiply by 3 to get 18? The answer is yes. 3 times 6 is 18. Then I go on to 4. There's nothing when I multiply 4 gives me 18. 5, no, we know from our divisibility rules that if this does not end in a 0 or a 5, we cannot use the factor of 5. So I'm done. So these are the factors that make up 18. So now we can do the same thing, but in a T-chart, 1 and 18, 2 and 9, 3 and 6. So that's how we find a factor of a number. Today, we are going to be finding common factors. So that means we're going to factor out several different numbers, and then we're going to circle the common factors in each in order to find our answer. So let's start. This particular problem says Chuck has a coin collection with 30 pennies, 24 quarters, 36 nickels. He wants to arrange the coins into rows. Each row will have the same number of coins, and all the coins in a row will be the same. So how many coins can he put in each row? So we know that all good math students circle important numbers: 30, 24, 36. We also know that we underline the question to make sure that we're putting the correct label on it and we're actually finding the correct answers. So what I'm going to do is I feel more comfortable lining my numbers up in a table. So that's how I'm going to make my list today. So I'm going to start here, 24, and then I'm going to do 36 because I'm going to need the factors of 36. And then I'm going to find my factors of 30. Now, for my friends who are able to use multiplication grids, I encourage you now to take out your resources because anything that you are given that is helpful, you should be using. So now we're going to start with 1, and like I said, we always go in order. 1 and 24, 2 and 12, 3 times 8, 4 times 6, can I 5? No, and then we don't repeat. So these are the factors that make up 24. So now I'm going to move on to 36. I have a feeling there's quite a few factors for 36. So let's get started. 1 and 36, 2 and 18. And if you weren't sure, this is where you would do the math on the side, just to double check. 18 times 2, yep, it's 36, because I don't want to make a mistake. 3, does 3 go into 36? Yep, 3 times 12. Factors with 4, 4 times 9. Oh, and then look at this, 6 and 6. Now, if we were writing this linear, you would only write the factor 6 one time. So now I have an awful lot of factors here. Notice my factors on the left are increasing, my factors on the right are decreasing. All right, let's find the factors for 30. So it's 1 and 30, 2 and 15, 3 and 10, 4, any factors with 4? No. What about 5, 5 and 6, and then we have 6. So we're gonna stop there. Those are all of the factors of 30. So now, what we need to do is we need to find a common number in each tree or in each diagram or in each T-chart. So let's start in order. So we have a 1, we have a 1, and we have a 1. So those are all common factors. Do we have a 2? Yep, we have a 2, 2, 2. Do we have a 3? Yep. All 3 numbers have the same number in common. If they don't, then you can't circle them. 4, 4, no 4. 6, 6, and 6. Now in this case, you only need to circle 1 6. All right, do we have any 8s? 8, 8, nope. 12, 12, nope. 24, nope. And now I'm going to stop there because we know that 24 is the smallest product or the smallest number, and there are no other numbers that are 30 and 36 or greater than 24. So we're going to stop there. But we're not done yet. We need to answer the question, how many coins can he put in each row? So now I need to list them. So I need to record the first common factor, 1, comma, the next common factor, 2, comma, the next common factor, 3, and last but not least, 6. So here's where we're going to put or 6, because he can put either 1, 2, 3, or 6 coins in each row. And you always want to make sure that you label your answer. And you know how I love for people to circle their answer to be sure that that's the answer to the question. So once again, a factor is a number multiplied by another number to find a product. You can do it linear or in a tree form. You want to make sure that your numbers are neat and organized and you start from 1 and go to the highest factor. You want to make sure that you circle each common factor, and then you want to put your answer over here and make sure it's labeled and that it actually answers the question. So this is an example of problem solving with common factors. Thank you.